ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಆಸ್ಟ್ರಾಯ್ಡ್ ಅನ್ನು ಟ್ರೇಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ದ equation of the asteroid is x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. So that is the given input. So given x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. ಯೂಶುವಲಿ ನಾವು ಆಸ್ಟ್ರಾಯ್ಡ್ ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಅದರದ್ದು ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ ಅಂತ ಬಂದಾಗ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಎ ಕಾಸ್ ಕ್ಯೂಬ್ ಟಿ and y equal to a sin cube t, and obviously t lies between 0 and 2 pi. If you want, you can mention it. It is understood otherwise. Less than 2 pi or less than or equal to 2 pi you can write, and we will assume a greater than 0. It's a positive constant. And one important point we have to keep in mind is minus 1 power 2 by 3 is plus 1 always. This point is very much important for the discussion of tracing of asteroid. So the idea of the tracing of asteroid is exactly the same as tracing of a Cartesian curve. Sometimes parametric form ಇರೋದ್ರಿಂದ ಬೇರೆ ಮೆಥಡ್ ಅನ್ನು ಬಳಸ್ತಾರೆ, ಬಟ್ ಕಾರ್ಟೇಷಿಯನ್ ಕರ್ವ್ನ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋದ್ರಿಂದ ಕಾರ್ಟೇಷಿಯನ್ ಕರ್ವ್ ಮೆಥಡನ್ನು ಸಾಧ್ಯವಾದಷ್ಟು ಇಲ್ಲೇ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಕೆಲವು ಬುಕ್ಕಲ್ಲಿ ನಿಮಗೆ ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ಗೆ ಬೇರೆ ಬೇರೆ ಥರ ಮೆಥಡಾಲಜಿ ಯೂಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. ಸೊ ಪ್ಯಾರಾಮೆಟ್ರಿಕಲ್ಲೂ ಮಾಡ್ಬೋದು, ಕಾರ್ಟೇಷಿಯನಲ್ಲೂ ಮಾಡ್ಬೋದು. ನಾವಿಲ್ಲಿ ಕಾರ್ಟೇಷಿಯನದ್ದು ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೇವೆ. ಸೊ ಇಯರ್ ಯು ಕ್ಯಾನ್ ಅಸ್ಯೂಮ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಕಾಮ ವೈ. ಯೂಶ್ವಲಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಕ್ಕಂಥ ಇಕ್ವೇಷನನ್ನು f of x comma y equal to 0 ಅಂತ ಬರ್ಕೋತೀವಿ. ಸೊ here f of x comma y is x power 2 by 3 plus y power 2 by 3 equal to minus a power 2 by 3. Okay, now let us analyze points one by one. So first point, symmetry. First point, symmetry. So symmetry ಅಂತ ಬಂದಾಗ symmetric about x-axis, y-axis, origin and the line y equal to x. So I have to verify 4 points. Whether the curve is symmetric about x-axis, y-axis, origin, the line y equal to x. All these points I have to check. First one, about x-axis. For this, you have to check whether if a replacement of minus y keeps the equation unaltered. That means in the equation you have to change y by minus y. If you get the same equation, then the curve is symmetric about x-axis. See, if you take f of x comma minus y, that is actually x power 2 by 3 plus minus y power 2 by 3 minus a power 2 by 3, right? This is nothing but x power 2 by 3 plus minus 1 whole power 2 by 3 into y power 2 by 3, but minus 1 whole power 2 by 3 is 1 minus a power 2 by 3, that is nothing but f of x comma y. So if you replace y by minus y, we are getting same equation. So curve is symmetric about x-axis. Okay, first point we had here. Next, symmetric about y-axis. So obviously we have x power 2 by 3, right? Even if you interchange x by minus x, you get the same equation. So curve is symmetric about y-axis. That is a simple observation. Now when the curve is symmetric about x-axis and also about y-axis, it is obvious that curve is symmetric about the origin. That is a trivial point. Next, you have to check whether the curve is symmetric about the line y equal to x. For that you have to interchange x and y. X power 2 by 3, y power 2 by 3. Even if you interchange, you get y power 2 by 3 plus x power 2 by 3 minus a power 2 by 3. There is no much difference. There is no difference at all. Sorry. There is no difference at all between these two equations. So curve is symmetric about the line y equal to x. Let us look into advantages. When the curve is symmetric about x-axis, we can just worry about the upper of plane, first and second quadrant. When the curve is symmetric about y-axis also, it is enough if you worry about the right plane. I mean, if you just worry about the first quadrant, same thing should be reflected in the second quadrant, and then whatever graph you get in the first and second quadrant, same thing should be reflected in third and fourth quadrant. ಸೊ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಸಿಮಿಟ್ರಿಕ್ ಆಗಿರೋದ್ರಿಂದ ಲೋವರ್ ಆಫ್ ಪ್ಲೇನ್ ಬಗ್ಗೆ ನಾವು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ವೈ ಆಕ್ಸಿಸ್ ಅಲ್ಲೂ ಸಿಮಿಟ್ರಿಕ್ ಆಗಿರೋದ್ರಿಂದ ಎರಡನೇ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಹೇಗಿದೆ ಅಂತ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಡ. ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಗೆ ಒರಿ ಮಾಡಿದ್ರೆ ಸಾಕು. ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಏನು ಗ್ರಾಫ್ ಬರುತ್ತೆ ಅದನ್ನ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ಗೆ ರಿಫ್ಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಇಂದ ಏನು ಗ್ರಾಫ್ ಬರುತ್ತೆ ಅದನ್ನ ಫೋರ್ತ್ ಮತ್ತೆ ಥರ್ಡ್ ಕ್ವಾಡ್ರೆಂಟ್ಗೆ ರಿಫ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಹೋಲ್ ಕ್ವಾಡ್ರೆಂಟ್ಸ್ ಅಲ್ಲಿ ಗ್ರಾಫ್ ಸಿಗುತ್ತೆ ನಮಗೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಬಂದಿಲ್ಲಿ symmetric about the line y equal to x. So symmetric about the line y equal to x ಅಂತಂದ್ರೆ whatever the graph you get in this region, same thing should be reflected in this region. So whatever graph you get in this region between the line y equal to x and y axis, same thing should be reflected in the below region. So you have to worry about only this place, this one or this one, and whatever you get in one region, same thing should be reflected in the other region. So this is the advantage of symmetric property. Now that is the first point we had. Next point, special points. You have to put x equal to y equal to 0 here. You have to put x equal to y equal to 0 here and then equate to 0. You have to take f of 0 comma 0 equal to 0. Then check whether you get 0 equal to 0. If you get 0 equal to 0, the conclusion is the curve is going to pass through origin. Otherwise, curve is not going to pass through origin. Now, if you take x equal to y equal to 0 here, then you get minus a power 2 by 3 equal to 0, which is not possible. So the conclusion is curve is not passing through origin. Curve is not passing through origin. So curve will not pass through origin. That is the first point you have to identify under special points. So next, you have to check whether the curve intersects with x-axis. For that, you have to put y equal to 0. Put y equal to 0. If you put y equal to 0, then you get x power 2 by 3 minus a power 2 by 3 equal to 0. From that, you get x equal to plus or minus a. Similarly, if you put x equal to 0, then y power 2 by 3 minus a power 2 by 3 equal to 0, from which you get y equal to plus or minus a. So curve meets x-axis at plus or minus a, and again the curve is going to meet y-axis at plus or minus a. See, if you take this one, this is the point minus a, and this is the point plus a, and this is the point say plus a, and this is the point minus a. The curve is going to meet x-axis at these 2 points, minus a and plus a, and again curve is going to meet y-axis at these 2 points. Okay, now point of intersection is over. Then asymptotes. asymptotes. And okay, here we can observe one more point, that is from the parametric form. We have x equal to a cos cube t, right? If you take mod x, then it is mod a cos cube t. That is actually mod a. I mean, this is actually less than or equal to mod a. Why it is less than or equal to mod a? It is actually mod a into modulus of cos cube t. But modulus of cos t is always less than or equal to 1. So it is less than or equal to mod a. Similarly, you can check that modulus of y is also less than or equal to mod a. The information that we can get from here is x and y, or the graph will lie only between these 2 points. You don't get graph above these points or to the right of these points. So the graph will exist only between these 4 points. We don't get graph out of these 4 points. So that is the point information I had to gather from the parametric form. Next, asymptote. Here we have equation x power 2 by 3 plus y power 2 by 3, right? Highest degree term in x is x power 2 by 3. It's parallel to x axis one though, and another one is parallel to y axis, right? Highest degree term in x is x power 2 by 3 and its coefficient is 1. So 1 cannot be equal to 0. And highest degree term in y is y power 2 by 3 and again its coefficient is 1. It cannot be 0. So there are no asymptotes. There are no asymptotes. ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ಆಕ್ಚುಲಿ ಇದರಿಂದನೇ ನಾವು ಕಲೆಕ್ಟ್ ಮಾಡಬಹುದು. ಹೇಗೆ? The graph is going to lie within the finite region. Within the finite region. Asymptote ಅಂದ್ರೆ ಏನು? Asymptote means it is a straight line that touches the curve at infinity. ಸೊ ಗ್ರಾಫ್ ಫೈನೈಟ್ ರೀಸನ್ ಒಳಗಡೆ ಇರುತ್ತೆ, ಇನ್ಫಿನಿಟಿಗೆ ಹೋಗೋದೇ ಇಲ್ಲ, ಅಂದಮೇಲೆ ಅಸಿಂಪ್ಟೋಟ್ಸ್ ಇರಲ್ಲ. ಸೊ ಇದನ್ನು ನೀವು ಇಲ್ಲಿಂದನೇ ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ಬೋದು, ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಇದನ್ನು ಮಾಡೋ ಅವಶ್ಯಕತೆನೂ ಇರಲ್ಲ. ಸೊ ರೀಸನ್ ಆಫ್ ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ ಎಕ್ಸ್ ಪವರ್ 2 by 3 ಪ್ಲಸ್ ವೈ ಪವರ್ 2 by 3 ಈಕ್ವಲ್ ಟು ಎ ಪವರ್ 2 by 3. ಎಕ್ಸ್ ವೈಗೆ ನೀವು ಯಾವುದಾದ್ರೂ ವ್ಯಾಲ್ಯೂ ಕೊಡ್ಬೋದು. ವಿತಿನ್ ಫೈನೈಟ್ ರೀಸನ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಮೈನಸ್ ಎ ಪ್ಲಸ್ ಎ ಒಳಗಡೆ ಯಾವುದಾದ್ರೂ ವ್ಯಾಲ್ಯೂ ಕೊಡ್ಬೋದು, ಏನು ತೊಂದರೆ ಆಗಲ್ಲ. ಸೊ ರೀಸನ್ ಆಫ್ ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ So curve exists at all points. ಸೊ ಇದು ತೊಂದರೆ ಇಲ್ಲ. ಸೊ ಲಾಸ್ಟ್ ಆಗಿ ನೋಡ್ತಕ್ಕಂಥದ್ದು ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಏನಂದ್ರೆ ಡೆರಿವೇಟಿವ್. ಯು ಕ್ಯಾನ್ ಚೆಕ್ ದಟ್ by differentiating this x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. ಇದನ್ನು ನೀವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ ನೋಡೋದಾದ್ರೆ y dash will be minus of x by y whole power 1 by 3. Actually minus x power 1 by 3 by y power 1 by 3 ಬಂದಿರುತ್ತೆ. So in the first quadrant, okay, ಇದನ್ನ ಇಲ್ಲಿ ಬರ್ಕೋತೀನಿ ನಾನು. So I'll get derivative to be y dash equal to minus x power 1 by 3 by y power 1 by 3. ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಎಕ್ಸ್ ವೈ ಎರಡೂ ಪಾಸಿಟಿವ್, ಆಬ್ವಿಯಸ್ಲಿ ವೈ ಡ್ಯಾಶ್ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಲೆಸ್ ದೆನ್ 0 ಇನ್ ದ ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್. ಸೊ ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಕರ್ವ್ ಡಿಕ್ರೀಸಿಂಗ್, ಈ ರೀಸನ್ ಅಲ್ಲಿ ಕರ್ವ್ ಡಿಕ್ರೀಸಿಂಗ್ ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕು, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಈ ಪಾಯಿಂಟ್ ಬರಬೇಕು. ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ, ಓಕೆ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ತಗೋತೀನಿ. ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಎಕ್ಸ್ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. ಸೊ ಒಂದು ಟರ್ಮ್ ನೆಗೆಟಿವ್ ಇದೆ ಅಂತಂದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ವೈ ಡ್ಯಾಶ್ ಗ್ರೇಟರ್ ದೆನ್ 0 ಆಗುತ್ತೆ. ಥರ್ಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಎರಡೂ ನೆಗೆಟಿವ್, ಸೊ ವೈ ಡ್ಯಾಶ್ ಅಗೇನ್ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ. ಫೋರ್ತ್ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ವೈ ಅಷ್ಟೇ ನೆಗೆಟಿವ್, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ವೈ ಡ್ಯಾಶ್. ಸೊ ಇಫ್ ಯು ಸ್ಕೆಚ್ ದಿ ಗ್ರಾಫ್ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ This is the graph of the asteroid. So this is the required one. So with this, the discussion of, I mean, say for reference, I have just written A, but actually I have to write A comma 0. This will be 0 comma A. Let us write it properly. ಸುಮ್ಮನೆ ರೆಫರೆನ್ಸ್ಗೋಸ್ಕರ ಎ ಮೈನಸ್ ಏನು ಬರ್ಕೊಂಡಿದ್ದೆ ಅಲ್ಲಿ ಸೊ ಪ್ರಾಪರಾಗಿ ಬರೆಯೋದಾದ್ರೆ ಇದನ್ನು ಈ ರೀತಿ ಬರೀಬೇಕು. So this is the required one. So with this, let us wind up the discussion of tracing of asteroid.